Hey guys, welcome back. Quick lesson for today. We're going to talk about graphs of polynomial functions, and you're probably going to want to go back to Desmos and try and look at some of the shapes of the polynomials so you can see them. But the one thing I want to talk about first is in the questions they talk about odd degree polynomials and even degree polynomials. So in this case, it just means that the highest power is even. So in this case, it would be like a second degree polynomial or fourth degree polynomial or sixth degree polynomial. And the odd, where the highest power is the odd number. So the highest power is odd. The other thing they like to think about is they have what's called the leading coefficient. And so that is the number that is in front of the term that has the highest exponent on it. So if it's positive or negative. And this, I gave you this chart here, which you are going to reference a lot or look at a lot. So that's why I gave you the whole chart in terms of what's happening with the polynomial when you have it. So it makes reference to odd degree polynomials and even degree polynomials. You have to then look at the leading coefficient, or what is that first number on the highest exponent variable, and whether it's positive or negative for an odd degree, or whether it's positive or negative for an even degree. It tells you the end behavior, so what happens as you go towards negative and positive infinity in terms of the graph. And then we have a quick sketch of it. So you notice if you have an odd degree polynomial with a positive leading coefficient, that its end behavior is also in the graph, where as it goes to the negative x, it goes down and towards negative y. And as it goes to positive infinity, the y also goes to positive infinity. So that's what it's telling you. It kind of tells you the shape. So all odd degree polynomials with a positive leading coefficient are going to look like this one. All of them that are odd degree with a negative leading coefficient are going to look like this. So they all have that kind of shape. They just differ in their maximum minimums and where they cross the axis. I also want you to note the domain and range for each of them. For any odd degree polynomial, the domain is x is in the real set of numbers, because it can be anything, and the y is in the real set of numbers because it can also be anything. The big difference here is when we get into our even degree polynomials, because x can be anything, but in these cases, we usually have a maximum or a minimum. And so we have to be careful that when it's positive, it has that minimum, and it always is above that minimum for the y value. And for the negative, it's always below that maximum value. So be careful with those ones. So let's move to the example, and we can quickly kind of go through this and how we kind of break it apart. We're going to consider the polynomial function f of x is x cubed plus 3x squared minus 4x plus 1. So the first question says, is this polynomial function an odd degree polynomial or an even degree polynomial? So when I look at it, it's x3 plus 3x squared minus 4x plus 1. So here is our highest exponent, and it is a odd. So we have an odd degree polynomial. Okay, b is the leading coefficient. Is the leading coefficient positive or negative? So we got to look at the number that's in front here, and because it's a 1, and there's no negative sign there, it is a positive leading coefficient. So I don't really care about the coefficients of the other numbers. I just care about this one that has the highest exponent on it. C, this is where the chart comes in super handy. We're going to describe the end behavior of our polynomial. And so you can just go right to the chart and find exactly where you're looking. So we've got an odd degree polynomial with a positive leading coefficient, which is in that first column. And so we can say as x goes to negative infinity, so as x is really, really low, then the y goes to negative infinity. All right, and then we can talk about the positive values. So as x goes to positive infinity, y also goes to positive infinity. State the domain and range of the polynomial function. And again, from that chart and from practice, the more you draw these and the more you look at them, the more you'll remember. But for the domain, x is in the set of real, so it can be anything. And also in this case, the range is y is in the set of real, so it can also be anything. So there's no maximum or minimum on these ones. That's kind of how you're going to break everything down. And then you can even, I could say, what is the shape of this going to be? And just based on our end behavior and our domain and range, you can, I know it's on the graph there, but you can see that it's going to have some sort of shape where it comes up and then goes in this direction. So it's going to look sort of like that. I'm not sure exactly what the numbers are, but it's going to have a shape that kind of looks like that. So go do the practice. Have fun.